This time I will show you how to design an overlay pavement using AASHTOWare software. So I am opening my software. It is licensed, so if it is not licensed, you cannot use it. I'm pressing OK. Then I will open a new project. Now here, when you are doing it, this portion is important. Design type. What kind of design? Is it new pavement or overlay? So I will do overlay. Overlay means I had a pavement, it was deteriorated, so we milled up part of it and we will place a thin new layer so that we can get that desirable service. So that is overlay. So there must be a old pavement. Okay, then pavement type, different points like AC over AC means as per concrete over as per concrete. That means I had as per concrete, it got deteriorated, and we milled up part of it and we will place a new as per concrete. So, and this way there are so many other ways we can do it, but this is the most popular. So I will do as per concrete over as per concrete. So if I did it, it shows the input level to be used for characterizing the existing pavement layer is required to be entered. Obviously, that means like whatever my old asphalt was, I need to give some information about the old material also. Okay, so it is showing two layers by default. That this is the new layer that I will apply. Say it is 4 inch. I can change whatever I like. 2 inch, 3 inch, 4 inch. I can change it year voids, effective binder content, all the parameters, and the binder type. What kind of binder I want to put in the new layer. So you can click, you can see viscosity grade, penetration grade, or super pay performance grade. Nowadays we use these. You can change like whatever your as per binder is. So do whatever is for your material, and then input type. That means you know what is input type, like the accuracy of the input. Level 3 means national average data, default type data. Level 2 means average type data. You do not have any exact data, but you will select based on your area. And level 1 means exact. You measure the material properties in your laboratory. So say level 3. Level 3 is already defined, but if you click level 2, you have to input it. So based on your laboratory testing at different testing time, at mid temperature, what was the creep compliance? And if you do it level 1, you have to do at 3 different temperature at different loading times, what was your creep compliance. And by this time you know what is creep compliance, because when you are studying this, you already finished that chapter. Okay, same thing for dynamic modulus. If you say level 3, then they will use the model or the equation to determine this. If you choose level 2, same thing. If you choose level 1, you have to define at different temperature, different frequencies, what is your dynamic modulus. You have to input it here, here, everywhere you have to input it manually. So as we do not have this data, we will go by input level 3. Same thing for creep compliance, we will go input level 3. Okay, so this is done. What about the old material? If it is old material, we have to select what was the binder. Say I'm choosing whatever it is, 64. Okay, choose 5834, whatever. Now it is not whatever, it is based on engineering judgment. Whatever binder you needed or whatever binder you used here, as it is old material, you cannot choose anything here. It is the old already existing. Okay, then input level for dynamic modulus, you can choose here level 3 or level 2. There is no level 1 for old material. Now, whatever you do here, you can see it is asking NDT modulus. What is that? Non-destructive testing modulus. That means you need to go to the field and determine the modulus of the existing layer using non-destructive testing. FWD is a very popular non-destructive test. FWD means falling weight deflectometer. I discussed it in my previous several videos earlier. What is a falling weight deflectometer? And I think by this time you know what is falling weight deflectometer. We carry a track, drop a load on the pavement surface, measure the deflection at various radial distance, and we back calculate using software. So you need to determine this. Say I am assuming here 500,000 is a very high number. Say at frequency say 10, and that time my temperature was 65 degrees Celsius. I'm just guessing something. Is it 500 or 50? 500,000 is yes, not is correct. Yes, yeah, 500,000 is still also very high dynamic modulus, and that is almost a new type. So 200, 300,000 is a good number for existing one. But again, you cannot guess it. You should determine it. Okay, so this two layer we already defined our material properties. Okay, then what we'll do, we'll oh, I clicked so many times, so my software got hanged. So I should be slow. Okay. Now if I do here, and now I clicked. Okay, I did not click. Okay, if I go back, so actually what I was clicking, I click then. Okay, so if I click here, pavement structure, if I expand it, you can see both are yellow. That means something missing, or the software is telling me go back and check. If I go back, I checked everything correct, and layer number two, it was 8 inch. You can change whatever you need based on situation is correct. uh, and this one everything looks correct to me. And then traffic, then you have to input your traffic, say two-way annual average daily traffic, whatever in your site you can input all this. You can input this distribution and growth rate. You can input this monthly adjustment factor. You can include this excel part track. You can include the input the load load distribution like excel load spectra or load distribution at different classes, different months, at different loading level. What was the percentage? It takes time to develop it. You need way in motion sensor to develop this. Now we will go as it is. Okay, now climate data, say I'm going here, say we are doing this time Wyoming. If I select this, no, I did not select. So if I search it, it will show. mm, yes, it showed some climate station. I told you earlier that in United States there are about 4,000. It's a rough number, maybe 3,000, 4,000 climate station. So as this software is a educational versus, so it is showing only several, I don't know, three and say eight station. So we will take anyone. Say this time we are taking this one, uh, Idaho. So we selected this one. So it is showing the climate. So climate is done. Okay, so if I go back to pavement structure, maybe I forgot something inside in pavement structure, which is I input only two layers. So I forgot to input about base layer and subgrade. I need to input it. Okay, so after the existing asphalt layer, I am placing a non-stabilized base material, say A3. Uh, uh, so I am inputting it here. Oh, what is the thickness of this layer? Okay, it is not showing the thickness, but as I will show another layer below the base, it will show it. So I am now inputting after base. There is a I am applying a subgrade. In every pavement this is very common. Say my material is A75. Now this is AASHTO classification. So based on your site condition, you will input it. So I am doing this. Now if I click it here, it is showing the thickness 10 inch. Yeah, maybe not 10, maybe 8, whatever. It is like whatever your site is, you will input that. So everything looks, yeah, green. So, and then I will choose my Excel output. That is very common. Excel output, yes, it will give me Excel output. So it looks that my project is about to run. And what I will do, I will save it. Say not project 1, say this time I will do project say 6. Okay, project 6, so I saved it. Okay, so hopefully you understood how to design overlay. It's the main difference is here. There will be there will be a new layer and there must be an existing layer, and I need to give input of both layer. That is it. And this will be for any pavement. There will be base layer, subgrade layer. If you do not have base layer, there must be subgrade. So based on situation, and you saw that the input are not surprising, everything is known to you. Maybe I did not discuss here. It is the your threshold distresses. So you will set it. Say you are saying my initial RII was 63 and terminal will be 172. That means when it reaches this, pavement fail. Similarly, all this threshold value you can change as you like, or as you need. So I saved it here. um, it is 20 years long. Looks so long to me because it will take time to run it. So I will do say 5 years so that I can finish the video very quickly. Here based on your need, if you are designing the pavement or overlay pavement for 20, do it 20. But I'm doing it here 5 because so that it takes less time to run it. Okay, so I'm saving it so that I do not lose my data. Then I will run. Okay, now it is running because I showed some changes and you will see the progress here in this screen. Okay, and maybe I did not discuss this portion here. Yes, I use the default value here, but you will choose this timeline based on your need or based on your site condition. I used here existing construction May 21 and pavement construction. That means the new layer you will apply in June. 1 year, after 1 year, it looks so long, but still it is just a learning purpose, so it is okay. So whatever your schedule is and whenever your traffic opening is, you can choose as you like. I am just showing here what is inside the overlay design, inside the like software. If you open the software, if you want to design your overlay, what are the like requirement or input, I am trying to show it. But again, in the like in traffic, in material traffic, with different layers, climate, you have the full flexibility of your need. Whatever your input is, you can input uh, whatever you want. And then after inputting everything, if you do not here, I selected show Microsoft Office Excel so I can see it. If you do not select it, you will get a PDF by default. Without selecting or no, you will get a PDF file as your output report. So it is generating the output. We will show you. Oh, it came. So the PDF file came. I am doing for 5 years AC over AC, and these are some basic information. This is my output. This is my output, and see here my target was 172 as my terminal roughness IRI. It predicted 112, so my pavement should be good. Say thermal cracking, my prediction was 1000 feet per mile, but I'm getting only 1 feet per mile. That means my pavement will be good. But again, it looks so over designed to me because see here your target is 25%, you are getting only 6. Or something here you will get a reflecting crack. Whatever your bottom of fatigue crack, you will get a reflective means whatever your old crack was, some part will be reflected. So total will be 6% only. So it looks to me that this pavement is over designed. You can go back and you may like to change your or decrease your new asphalt here. Excuse me. At the same time, yes, or you can choose some inferior quality material at the surface, so you do not need it. But that is a different or separate discussion. Design is never one way, it is a loop. That means you design something, you are not happy with something, go back, change some material or layer, and rerun again and see the output. Okay, if I want to go show you the Excel file, my project was 6, and the Excel file you can It looks something wrong. Okay, so I don't know what happened here. Ideally you should get a Excel file. Now this Excel file is from another project, uh, but again you should expect a Excel file, or I did in X. I No, yes, something wrong. Maybe this is educational purposes, but whatever in the PDF file, you should get Excel file. If your software is a regular software, standard, you purchase it, you should get everything. But you can see that whatever your input here, they are showing all the input, and they are showing all the outputs, like crack, deformation, everything. They will show you one by one. So hopefully you understood how to design overlay. Mm, Okay, so I will stop here. In the next video, I will show you another design, same maybe concrete pavement design. I do not want to make my video long so that you do not see it. Okay, so I will stop here. See you in your next video. Thank you.